everyone. I'm Ben Bogue. I'm a builder down here in Connecticut, as you can see indicated by the asterisk on our lovely new backdrops. Um, Tonight's topic is While My Window Gently Weeps, Keeping Water Outside. BS and Beer is an independent grassroots movement to share building science knowledge through local meetup groups and this, our Zoom show. The Brew Crew and our guests volunteer our time each month to bring you what we hope is a fun and informative discussion. We encourage you to find a local BS and Beer discussion group or to start your very own. Visit thebsandbeershow.com for more information. Post questions and comments in the chat box. Be sure to click all panelists and attendees or everyone. Otherwise, Zoom tends to revert it to panelists only, and we have a hard time keeping up with all the chat flying through, and people won't be able to see your comments. The video recording of tonight's show will be available on our YouTube channel and through a link on our website at thebsandbeershow.com. And we would like to thank Green Building Advisor and Fine Home Building for their past help with the show and with swapping over to our new independent Zoom platform.
And with that, because it's left over.
Off to Mike.
Thanks, Ben. Mike Maines in Maine. I was down to the wire, so I am drinking a lovely glass of tap water filtered with the PFAS filtered out, hopefully. Announcements. IBS and NHB's International Builders Show is coming right up later this month in Vegas. Once again, Travis, Ben, and team Travis and team will be putting on a one-day building science symposium the day before the show officially starts. I don't remember the days, but I think it comes up here. Travis and Ben are heading up the construction performance zone again, which has live workshops on the show floor all day, every day. Early registration discount has passed. I don't know if there's any room left in the symposium, but you can check it out in case there might be.
A little bit.
I'm sorry, I did not get this our document updated as well as I should have. Also, Huber is sponsoring for any BS and Beer organizers. Huber is sponsoring a meetup for BS and Beer group organizers at 10 a.m. on the last day of the show. I believe that's a Thursday. And I will put a link to that show in the chat box. And I would like to thank a few new team members. Charlotte Mustard and her team at IMW have been helping us a lot in this transition to us being more independent, and we're also working with Doug Duval. I can't remember his business name right now.
Motif.
What's that?
Motif.
Yes, Motif. For our video editing and related things like that. And Doug also works with Peter Bowring, who happens to be the Boston BS and Beer local organizers. And Peter has put together these lovely new backgrounds for us. So thank you, Peter. I think I saw you on the call. And I will turn it over to Travis.
Yeah, I love the new fancy background. Yeah, I get the pleasure of introducing Peter Yost, but first I'm going to introduce myself. I'm Travis Brungard. I'm in Kansas City. I'm a custom builder here. And tonight I'll be drinking one from the private stash. That's a Jew brew. You can't get this on the shelves, folks. My friend Dan Edelman sent me this Alfred 2024 Belgian double. So after I finish my triple espresso, I'm going to have a little chaser there. So thank you for that, Dan. Now on to the show, right? Peter Yost is the sole proprietor of Building Right. That's in the website with a W. And Michael dropped that in the chat. But Building Right is Peter's company where he's been building, researching, teaching, writing, and consulting on high-performance buildings for more than 30 years. His expertise ranges from construction waste management and advanced framing to energy efficiency and building durability. His work has included technical director of Green Building Advisor, lecturer at Yale University's School of Forestry and Environmental Studies, an instructor for Boston Architectural College, adjunct faculty with University of Massachusetts Amherst Building Construction and Technology Program, and faculty for Keene State College's Architecture Program. He's also a certified or certifiable wingnut. I always think of Peter for his rock climbing tips, but tell us, Peter, what did I miss in the introduction?
Oh, that was such a nice introduction. I've forgotten the beginning of it, so I think we're all set.
Fair enough.
It's great to be here. I guess I'll show you that I am drinking Athletic Brewing Company Upside Dawn.
That's a good one.
These are new to me, the non-alcoholic, and my wife and I are doing a lot of switching back and forth from real stuff to non-alcoholic, and there's so many varieties now that have, like I had a Belgian white the other night, and it's pretty close to the alcohol one, so it's all good. And with that, I'm going to share my screen with the PowerPoint. Does that seem like good timing?
Let's party.
Let's do it.
Okay. And now I've got to move all these other screens out of the way so I can see what the heck I'm doing here. Hold on just 1 second. Yikes.
I love Zoom for that. Every time you screen share, it's like everything just like goes to the corners of the earth.
Yeah. And this
Super
one I need to
intuitive.
get rid of. I think I can, well, if I close something, I'm bound to screw it up. Okay. I think I've got it now. Um, one more, I guess what I should do is turn off mirroring, but might be a little bit late for that. Okay. Um, so I'm going to launch right in. You can see the title slide, but yeah, so this wingnut stuff, the idea is that this is actually protective gear. And it's probably OSHA approved, but who knows? And it's protective gear because it protects you from lawyers. I mean, who's gonna take something that comes out of the mouth of a wingnut and hold them liable for what they're talking about? Um, but it also for things like we're gonna, I've done a lot of different wingnut testing, and it's basically just trying to field test or bench test without ASTM conditions. And so I do have a YouTube channel. I'm sure it's not competitive with people like Steve Basic. Ah, he won't wear the hat, by the way, although I'm happy to get him one. And by the way, these are from the Detroit Red Wings fan club. That's how you get a wingnut hat. And they're politically correct because there's a right wing and a left wing. But they don't make them anymore. So now they're collector items, sort of like old people. But you can look at my YouTube channel for a bunch of stuff regarding wing nuts. But it is mainly that we do a lot of serious work, but it does usually involve alcohol and it's sort of tongue in cheek. And so kind of the best way to approach when you're trying to do something innovative and you're really not sure what you're doing. But on this particular topic, you know, um, in the last 2 years, I have been involved in three projects, top-notch architect, top-notch builder, trained crews, and the windows were installed wrong. And so I think we're doing something inherently wrong with window installations. And my buddy Steve always says, don't fix something that's not broken. And I think it is possible to get, even complicated window installations right. But when we have examples that all the conditions were perfect and we still didn't get it right, there's something that would give you pause there. So this building won an architectural award. It's really crazy ass complicated. Um, but I want to draw your attention to this stair tower. This window is about 22 feet tall, maybe 18 inches wide. Um, this is what the stair tower looks like from the inside. So this stair tower, of course, is steps going up. They twist and turn to get from one level to the next. Um, that's what it looked like when they took it apart. Um, the installation of these windows was really complicated. They didn't get it right. Actually, these windows were reinstalled once before we got to this stage. Um, and part of it is that, like this is the rotunda that's about 45 feet tall. All these windows are 360. They're flat windows and a round opening. You can see them installed from the inside here. But I'm showing you this building because this is the detail that was drawn up by the designer for the new configuration. And this is like after going over it with the site manager, the project manager, the architect, the structural engineer, um, myself as the enclosure consultant, and the drawing is still wrong. And it's because this is just a really complicated installation because of the geometries, but also because of these big subsills. Um, why is it installed wrong? This weep here that that takes water pressure off the bottom of the IGU, it doesn't weep. It goes right into blocking. Um, so I'm going to show one of Steve's slides from one of his home building crossroads presentation. And again, Steve knows exactly how to achieve the perfect drainage plane and air barrier to get this window to work right, but it's really complicated and it's different from other installation he's done. Now, part of that's because this was a remodel, but our window installations, I think we need to do bring more high performance to them. So what does that mean? What is the problem? This is my opinion. Installs are too complicated. Installs are often custom and unique. There's too many variables: type of window, depth of wall, plane of WRB, plane of the window install. You know, are aligning these things going to make it easier to get them right? Would it be better if they were more protected deeper in the assembly, where you have to drag the details back and forth if the WRB is in a different plane than the window installation? Um, Manufacturer instructions. Steve and I have been looking at a project out in the mountainous west, and you know, the instructions are pitiful compared to the complexity of the installation. They're basically sort of cover your butt, hope good luck with getting them installed water and airtight. And then, this is a constant problem because, most manufacturers, they figure out how their product works in isolation. And building enclosures are all about piecing things together. And so when we talk about responsibility for opaque wall compared to a penetration and then what goes into that penetration, generally there's just a lot of finger pointing about who is not responsible for making sure that the overall assembly performs because the individual components are integrated and work with each other. So what do we do? So I often say in presentations that you can take one of the least expensive cars, 5 years old, drive it 70 miles an hour into a rainstorm, and they don't leak. And yet we have buildings that sit still that leak water. And so one day I was thinking, well, okay, if that's true, why don't cars leak? So I started to look at gaskets. And car door gaskets are super interesting, I think. And look at this situation here where the cavity between the door and the vehicle frame has lots of airspace. The primary bulb is, it's a flexible pressure bulb, and it's against a pinched gasket on the inside that's mounted to the flange. But what's really interesting down the bottom is that this drawing that I found, the title of the article is not about water, it's sound transmission through elastomeric bulb seals. So hold that thought in terms of looking how cars and car doors work. So I started to look more carefully at car doors, and they're super interesting because they are double bulb gaskets, one installed in the frame and one installed on the door. But the hinge and the closure mechanism, they are outside of the gasket rings. And so that's the way you get them continuous. But there's only 2 points of contact for that door. The rest of it is just bulb meets bulb. The other thing that's interesting is, that diagram that I just showed, if you noticed, that was dated 2003. And that's pretty interesting because when I started to research back through different age cars, you can go back at least 10, if not 15 years, and the gaskets are eerily similar. But when you go back 20 years or more, there are a lot of different ways that doors were set up to, complete the closure, given that these doors are opening and closing all the time, and the gasketing has to be continuous. So first thing is, you're draining the rough opening. I know I'm quoting that from building science, but everything is designed to drain out the bottom of the door. So that's the first thing. The second thing is that the car door gaskets are always bulbed and they're always perforated. They're always continuous. They are incredibly custom, right? These gaskets are very expensive. And by the way, gaskets are available for our industry, but they're rarely used in place of pressure-sensitive adhesive tapes or liquid sealants because, relatively speaking, they're a lot more expensive per lineal foot than either of the other two. Because car doors open and close over and over again, they don't have the luxury of using something that's more permanent, like the windshield, for example. That is sealed in a very different way, but that's related to the fact that the windshield hopefully is always closed. You can see the perforations here. I didn't know they were perforated until I started to peel these gaskets apart. So the perforations are hidden and they generally face either up or vertical. They're not there as weeps. They're there as pressure relief. I'll come back to that a little bit later. Um, Car door gaskets are incredibly heavily shielded. If you look at the distance from the gasket to where the actual door overlaps the frame, it's hefty. It's only the closest at the pillar where the door latches. Everywhere else, there's a big shielded area until you get to the gaskets. So, you know, take your car to the car wash, and this is quite a pressure test because first we blast it with water, then we blast it with, something that reduces the wetting angle, soap. And I thought, well, I should be able to get my car door to leak because this is incredibly high pressure water and I'm blowing soap off. But I happened to find some bits of trash in the car because it occurred to me what I could do is take a wick, like a wrapper straw piece of paper, and if I stuck it halfway out into the space between the gaskets, then I could tell how wet the space got um, where the gaskets are. And so I put a bunch of these telltales, in the bottom of the doors, sides of the doors, different doors. Um, and so this spot is right here. After blasting this with soap and 2 bouts of water, one before the soap, one after, the gasket's perfectly dry, and so was the wick. Not only that, but this dirt, which is actually, I think, probably here, it's still there and it's dry. So most of the water's not even getting to the gaskets. So I figured now I need to get some adult supervision as to why car doors perform the way they do. And some years ago, under an NDA, I did some confidential work for an automotive company that was trying to build modular housing. And their idea was, well, we know how to make things in plants, under real controlled conditions. Let's take what we learned from assembly lines of cars and see how well we can do with modular housing. So I hadn't heard from this guy in a while. He does go to Joe's building science summer camp. But I called him. I said, hey, look, I need to understand how car door gaskets work. Can you connect me with somebody in your company? And he said, no, I don't think that's going to work. And I said, why? He goes, well, it's really proprietary stuff. And I said, yeah, but I'm not a car manufacturer. I don't really care. I just need some adult supervision. So he said, okay, what I'll do is I'll talk to the head of the department in automotive that deals with doors, windshields, hatches, and skylights. They are called the enclosure team. Do I have that right? I think that's the term they used. And so there's a team of engineers, and all they do are all the penetrations, like windows and doors. So he sent the head of this engineering department a picture of me with a wingnut hat on, and who can resist that? So I was told that I could talk to him for 1 hour during the lunch. The company would not know that he was talking to me. And he said everything that I tell you, you can use because I'm not going to tell you anything that's going to get me into trouble. So with that backdrop, um, here's what he said. First thing he said was, "It is rocket science," um, because both Steve Baising and I like to say, we quote Joe, that it's not rocket science, it's building science. And the first thing this guy said to me, and I hadn't told him about that expression in our industry, he says, "It is rocket science. It's really complicated." And it's in part because the seals, they're actually as much about acoustics as they are water management, if not more about acoustics. Because he said the thing that gets them in trouble, in addition to doors and windows leaking, is noise. And so their job throughout, the assembly of all parts of the car, but particularly the doors and windows, is managing the acoustical transfer of sound through those assemblies. Um, and we'll come back to that in a second. Um, the other thing he said is that the bulb gaskets, they really have to be sheltered. They are very susceptible to breakdown by UV and certain chemical exposure. So he said these suckers have to be completely protected from those things and water, because the mix of UV, water, and chemical exposure is like a bit of a cocktail. Um, you got to shield these from these agents. The trick with car doors is, or any type of gasket, is turning corners. And so you can see that with all the variations in the doors assemblies, how they turn those corners, how much they push the manufacturers of the gaskets to change properties to allow turning corners, because when you turn a tight corner, you can lose some other properties that you want out of that bulb gasket. Um, there are probably a half a dozen global suppliers of these bulb gaskets. They all have tiny little secret formulations, but these components have been converging. So when I asked him about all the 2022 and newer cars that the gasket systems look almost identical, he said, "Yeah, and you'll see a lot of stability over at least the last 10 years because we've gotten where we're probably as good as it's going to get with trying to optimize the performance of these gaskets." And then he said, the two big things you're going to have to focus on is that car doors, there's a lot of movement, a lot of the vehicle flexes a lot, and the different components flex in different ways, like when you go over bumps or things like that. So he said we have to have a lot of flexing built into our system, and because it's repeated open and closing, that these are two things that you're not going to see a lot of, repetitive motion and flexing. We will get some, of course, from wind pressure and so on, but not the way that cars see them. And then, we only have to get this right once. We're not open and closing the installation of the window. Um, and he said your turning radiuses are going to be a lot tighter um, than with us, because we have enough overlap with our shielding that we can sort of move the gasket around to make the turns more gentle. So I got 1 hour with this guy, but it was really, really helpful to understand what a gasketing system in windows would have in common with cars, and a lot of good adult supervision on when they wouldn't. So, for example, so what are we going to do? We're going to rely upon gaskets pressure clicked. So we're gonna make sure that when we get them with the gasket right up against the window frame and the building frame, that we have just enough pressure to get the water and air movement resistance that we need. We're going to install the windows from the interior. Sorry, I'm blocking part of my own view here, so I've got to move this sucker if I can. Sorry about that. Um, uh, and we're going to create a buck or a stop and push the window against that in the enlarged opening. We're going to use one gasket. I think this is the biggest thing that I learned from the automotive. The engineer I talked to said, the reason we use two is because of the flexing and the opening and closing. So you probably can get away with one gasket rather than trying to mate two bulb gaskets. And then you have to use that gasket as your stop for water coming in and air coming in or moving out. And so that brings me back to the fact that maybe we don't have to perforate our gaskets because they perforate them. I asked him, I said, what would happen in your car door if you didn't perforate the gaskets? He said, well, it would never close. You'd like press it and it would spring back, and press it and it would spring back. So we perforate and hide so that the door closes easily. With your situation, you might be able to put just the right amount of pressure, keep the pressure in the gasket system because you can compress it and then click it and it just stays at that level of compression. I'm going to come back to that a little bit later. Get rid of flanges. You know, in the olden days when we did deeper walls, windows were never installed either flush or sticking out into the weather. They were sheltered. And we sheltered them because we didn't have fancy sealants. We didn't have PSA tapes. We didn't have EPDM gaskets. So the way they protected the windows was largely, you know, inert brick and masonry type wall systems, and then the window tucked way back in, so it just doesn't see much water. You know, when I started to be a carpenter with our windows, we would trim them out with casings, and then the casing is the flange. And so you push the window in, and your flange is the trim. That means your entire window is only flush at the outside, but the rest of it's tucked in. What do flanges do? I mean, it's kind of the stupidest thing from a physics point of view. The flanges push 1/4 to 1/3 of the water outside the plane of the wall. Like if you want to make something cold and have it see more water, that's what you do. So I think we kind of headed in the wrong direction. We do it because it's easy and it does make the installations more uniform, but not these days. Because these days we're built back to building largely deeper walls, and now we're messing with, you know, all of you who have made bucks to accommodate flanges as opposed to just dropping the flanges to tuck the window back in. It just gets complicated. And I think we are going to have to determine responsibility because the only people that like the problems we have with responsibility are the lawyers. And then to me, collective wisdom, and this is where it ties in with wingnuts. You know, when we had a building group in Brattleboro, there was a quote from, I can't remember his first name, Levinson, a journalist from the 1920s. And he has a whole bunch of quotes on the, you know, on the internet. But one that we used in our group was, you must learn from the mistakes done by others. You can't possibly make all the mistakes yourself in one lifetime. So the thing about wingnuts is, you know, if we get people thinking about different ways to think about building materials, and some of those people have different backgrounds, that will strengthen where we head. And I'll give you some examples of that in just a second. I'm almost done. Okay, so I hope this is going to work. I'm going to click on this video. It's a couple of minutes, but it's my narration for this first demo.
Over the last couple of days,
can you hear that?
The first demo, and you can see here on the bottom, that is my 2x6 window, no glazing it, of course. And up at the top here, that's my framed rough opening. That's made of a 2x8. And you can see that I've added to this 2x2 stops around the jamb and the head and not at the sill. I was originally going to have this gasket installation be with the gasket running on the inside against 4 stops, including the sill. But that makes it really tough to do a drained rough opening. So you can see from the interior, here are the stops, the jamb head and the jamb. And then you can see the gasket here. And that gasket goes all the way around the stop and makes a complete gasket. And you can see rounded corners, because that's what you have to do with a gasket. You have to round out the corners. But then when you change planes at the bottom here, you get a crimp in the gasket. And that's something we have to overcome. But this is how it works. This is the window. I've got shims. I'm going to keep it up off the shims as I slide it in so that I can set it down. And now I have the gasket right up against the window frame. And that gasket is continuous all the way up around and also at the bottom. And so in this way, we can simply insert the window in the interior and then place the proper amount of force to really seat the gasket against the window and the stop. And maybe we'll be able to get a continuous, watertight and airtight bulb gasket installation. Once again, 2x2 stops at the head and the jamb, a flashed sill for the rough opening, and then I place the gasket, the bulb gasket, all the way around the jamb, the head, and on the sill I switch and put it on the flat sill. But every place where the gasket comes up against the window, it compresses. I'm not sure exactly how much it will need to be compressed, but that's to be worked out. And you can see that these shims I put, these are 3/8, and the gasket is about a 1/2 inch to 5/8 tall. And that's so that when the weight of the window comes down, it compresses the gasket, hopefully just the right amount. When I did a flashlight test, I had no light leaking through anywhere except where I expected it, which is right at this corner. This gasket is an EPDM bulb gasket with an adhesive, and the adhesive actually adhered very well to the zip tape and the stretch tape in this window installation. Hope this helps you to understand the gasket window installation demo, round 1. All you need to do is add glass. You can see the water would run down between the gasket and the stop and the window frame. And then we have a back dam. Can't really see it, but deep in there, that's the bulb gasket on the sill. And so water would run down. Now, one way we can protect the exposure of the gasket to sunlight and the direct force of water is to trim out the window to protect the tucked in gasket from both UV, which damages the gasket, and also so it wouldn't experience the full force of any driving rain. And of course, all those dimensions would need to be worked out. Signing off.
So this was demo number 1, and I did this for the Chicago BS and Beer. And, you know, there's going to be more questions than there are answers, but it's this type of demo, if enough people see it, will get the juices flowing. And so I wanted to share with you another video. Sorry. So in preparation for Build Show Live, where I was going to be doing so this was October, and then a month later we were going to be doing the Build Show Live in November, and Matt Reisinger at Build Show got us hooked up to Octoplast, and they're in Poland, but they said, well, you should really start talking to Cody Pelletier. He is our main representative for Octoplast windows at a design center in Boston. So this is Cody, and when Steve and I started to talk to him about this idea of gaskets, he like got super interested. He asked where he could buy a wingnut hat, and in preparation for us working together on the presentation at the Build Show Live, he sent me this video as part of the prep.
Hey, Peter, so what I used was at the bottom, I did a 3/8 window seal because that was the biggest they had at the store handy. But I did that across the bottom so that you can see that we're making at least contact in multiple places. But again, there's that one chamber where all the clip fastening ends up happening in the European style window. So I figured having a wider gasket that will make contact in multiple places was a good idea. I've got the shims that the window's going to actually be sitting on. And then I used a 5/16 by 30, 5/16 by 19/30 seconds. Gasket looks like this. I cut a V into the corner so that I can make a nice tight radius and have it lay for the most part flat, both corners. And I dyed that straight into the gasket.
Okay, so a couple of things here. Cody is already riffing all over the place with how to make this work. And interestingly, when I did the presentation in Chicago and I was talking about the crimp, Steve Basic walked from the back up to show me how he sliced the crimp to get it to fit and maintain its bulb in the corner. And part of that is because Steve has been to so many window manufacturers that he knows a lot of the techniques they use. So this is exactly how collective wisdom works. I come up with a wingnut idea, but I'm serious about it. And then people with different perspectives or more knowledge than I have start building on that. So Cody we presented together at Build Show Live. He already has 3 new configurations he wants to test. And he has a company he uses, a lab in Boston, to test windows. He and I are going to take these 3 configurations down there in the next month or so and submit them to ASTM pressure testing. I think it's 5.24 pounds per square foot pressure to test these to make sure that they pass. And then the next step would be to go to Poland and Octoplast to work with their engineers, because one of the things Cody needs is there's a component that you can clip into the perimeter of the window so that rather than it being a ribbed frame assembly, it presents a flat edge for the gasket. And then the last thing I wanted to show you.
Hey, Peter, so what I use.
So this is a drawing that was sent to me. Yosti Sieverding is a young engineer. He works for a building company. He came up to me after the presentation in Chicago and was telling me about this stuff, but I had to catch a lift to get to the airport, and I was trying to be polite, but he was like, I'm really excited about this. I think this might go somewhere. And so like a week later, he sends me these drawings of what he's thinking about. Now, his approach is very, very different. He wants to build like uh, a window component frame that flanges and then ducts into the opening, and then the window would clip into this. So imagine if these sort of four corners made out of either plastic or metal. There's fin gaskets here, there's a bulb gasket here and here. They run around the assembly. But what if these were corner pieces that overlapped? So Yosti's idea was, well, we have to be able to easily accordion for different distances into the rough opening, but then could we also sort of build four corners with long flanges so that they would meet a larger range of windows? Um, this is what he came up with in a week because he's a process engineer and he was trained to do exactly what we're doing, which is try to make a system that makes things more consistent and yet makes them more flexible. So other people have been weighing in, but I'm going to wrap up now. But we just need more people to think that their experiences and their different trainings can lead us to better solutions to the problems we have in buildings. So I've tried over and over again to sort of get a critical mass. Nate Guzikoff is a building enclosure consultant in Middlebury, Vermont, and he sort of took over the wingnut charge. I sent all my lab stuff to him, but he's so busy with his business that we're just not getting time to do wingnut stuff. But he did build a website, and it's called the Wingnut Collective, I think is the name of it. So we're getting there, because one of the things we need is not just people meeting up at conferences. We need a place, a repository to create a much more powerful intersection of people that come from different backgrounds. So that's it. We're still working hard on this. I can't wait to actually do some water testing. Koto Ueno from Building Science Corporation, I sent him an email after he'd seen this presentation. He weighed in with some really interesting perspectives, including building science insight that Joe Stiebrick did on water pressures. Everybody's doing this in their spare time. Yosti thought he might want to consider pulling a patent. And that kind of slowed down on our working together, because I said, hey, look, this is all open source. No one's making any money off this, at least not yet. And so if it's open source, that actually protects other people from pulling patents, because the nature of it is to share. And eventually, like a couple weeks later, he said, no, we need to continue collaborating. I'm not going to pull any patents. We're just going to keep working at this as a bunch of wingnuts. And interestingly, his approach, he thinks that his component system might be more related to wall assemblies than it is to windows. So to me, the big problem is that there's a bunch of people that design the opaque wall, and then they put openings in it and they turn it over to somebody who's sticking something into that opening. Those two entities have to work together. The people that are developing, like Huber is doing combined function, right? With their sheeting products. We need to extend that sort of combined function into penetrations. And so I think Yosti's approach is really interesting, because he's looking at it as penetrations as part of a wall assembly. And I had never thought of it that way. And I forgot to put these pictures in the slides, but you probably already thought about this. There's two ways to put a gasket on. you can either put it on the stop in the field or you can put it on the window frame in the factory. That's another really, really big decision. And there's pros and cons for both of those perspectives. Okay, and with that, I'm done.
You've only just
Okay, I have
begun.
about 3 million questions here.
Yeah, I
All
told
right,
everybody I have a hard stop at 7:30, but we got time.
all right. I'm going to be selfish and get one in for myself here first, and then we'll go into some others. But doesn't this, in essence, kind of need, you're treating these windows like a barrier system in a lot of ways now. I understand that it's drained at the face and somewhat back, but wouldn't this drained cavity need to go all the way back to at least the inner edge of the window? Otherwise, we need to rely on window manufacturers to truly create effective weep systems to push it out to the face.
That's an interesting perspective, especially since the other half of this presentation, when I did it for uh, BS and beer symposiums, was weeps, because weeps are, I Steve and Jake and I went to like 12 different window manufacturers 2 years ago at IBS. And we had 3 manufacturers say, well, we do put weeps in these windows, but in the other models, we don't. And I thought, whoa, so you can make a window that doesn't need a weep? Okay, so which one should I pick? The one that doesn't need the weep or the one that has the weep? Um, so this whole issue of what they do, uh, how do we treat them? You can put them on the face of the frame. You can put them on the underside of the sill. What are the advantages and disadvantages of that? Um, there's just that's another part of windows that I think are a bit mysterious, um, because the main function of the weep is to drain the water from the base of the IGU. Because if water sits against that seal, those seals hate liquid water. Um, so the main function is to drain the the bed in which the IGU sits. But many triple pane window manufacturers have so many chambers, they get to drain the whole bloody thing, starting with the IGU. So that's a good point. Do we need to integrate weep function with a system like this?
And then isn't this relying also on the effectiveness of the flashing to this buck system that we've created? Have we not just moved the goal line to another location now?
Um, you're right. We still have to use a lot of flashing tape. And that's because over the years, I've gotten a lot of support from the flashing tape manufacturers. We got to keep it in there. No.
I appreciate the honesty.
Um, yeah, I have 2 answers. One is I don't frickin' know. And the second answer is I think that this is a better use of the tapes and a better use of the gaskets. The other thing I forgot to mention is that when you install them from the inside and they click into place, from that point on, everything should be easily disassembled. So all the trim pieces, they should go in with trim screws. Because literally, if I have a problem with this window, I pop off the window trim, I press in to release the clicking of the compression mechanism, and I pull the whole window out. It's not taped in, it's not sealed in. That gasket allows me to just pop the whole unit out.
So the main issue you're trying to solve it is how to efficiently install an in any window versus a flanged window. This is how do you install any window effectively? Is that the crux, would you say?
Well, I'm trying to get us to at the least make the window installation flush. The outside face of the window unit should be no more than flush to the opening, if not recessed. So that's one thing. I think we have a lot more control when we install from the inside than the outside. And this could become a standardized system, more like a car door. And remember, they started out doing very different things, but they converged. So I think there's the opportunity if we get window manufacturers and or wall assembly folks involved in this, maybe we can get a much. It's we're not being fair to our carpenters. You know, they're just exceedingly complicated,
Mhm.
and and when we get to a different job, you know, the window's tucked in less, or the WRB is in a line rather than not aligned. It's I think that it's the responsibility of the people who make the products to systematize this because it's getting too complicated and too different for each job. So if we make it more converging, um, I think that it's going to be a lot easier to get quality installation.
Sure.
I love this.
And I'm just going to say this, although we have a lot of questions. Steve and I do not see eye to eye on this, but that's a good thing.
It's
It's
always
also
good to
really
disagree with
interesting.
Steve.
It's also really interesting that I couldn't figure this out until I actually built the mock-up. Steve couldn't figure it out until he drew it. I mean, that's really cool, right? I'm not an architect. I don't know how in his head he does 3D to 2D. I need to take the 2D to 3D. I need a model. So
I love the idea of this becoming a problem for our window manufacturers. I always I rage against ordering fajitas at the restaurant because when it arrives to me, I have to put it together. And I went out because I didn't want to do it. So if I order from the manufacturer a window that arrives to me with a face gasket, top and sides that is already integrated and sealed underneath with the bulb that you've shown, and then it has a little, I don't know, at the appropriate locations on the sides and head, little flip out tabs that I can go ahead and screw the bastard in. That is a really low lift for them who are already in a manufacturing setting, who already have operations engineers that could potentially then protect it in a box, ship it to me safely, and then it could be installed easily because it would be the same thing over time. Because that's the challenge that we're facing. Armando's been raging in the chat about the challenges to our labor pool and the difficulty of this and why we need flanged windows. And there's some truth in what he's saying for sure. The labor is really, to your point, we ask a lot of our carpenters, it's too many different variables to solve for. And by making it a system, I think you're onto something. I'm all in. Sell me your windows, Peter.
all right, well, I'm going to send you your hat first of all.
Nice.
And an invoice.
So
That's
so
right.
we tend to think that, you know, the innovation comes from the manufacturers, but when I was working at the NHP Research Center, the R&D folks were dying to work directly with practitioners because they are making components for people who build houses. So they need to truth test or figure things out with practitioners. It's not going to work if it's something that comes sort of out of left field. Um, and I think it's really cool that, you know, the whole thing will get better as we get more branches of our industry trying to figure it out.
Yeah. Or beyond the better energy performance of insetting windows and better resistance to stormwater. I like it architecturally. I always push for innies or middies or something because it creates shadow lines. Just people always like traditional homes, but don't always know why. They just know they don't build them like they used to. Having done lots of renovations, that's mostly a good thing. But what old homes have is character on the facade, shadow lines. And
Yeah.
modern architecture, modern design is very plainer. And developers have tried to sort of recreate that articulation with different materials and the telescoping gables and all that stuff. But if you just push windows in a little bit, you get some really nice shadow lines that gives the facade a lot more t- t- texture on its own without having to go through all these fake sidings and layers.
And it's too bad we didn't get the video from Build Show Live because Cody worked out. We Velcroed trim pieces for the jambs and the head, and it is like a car door. You can actually create a chamber that will shelter the direct force. It's gonna go in and deflect, just like it does in a car door. It's a narrow gap, but it's long. It's deep. And then we fashioned what we called cover metal sill, so that completely covered the stretch tape and then protected the bulb. And all we would have to do is put ribs to stand that cover metal off so that it would form basically baseball UV protection and again deflect water at the sill, and it looked great. And we actually did it with one of Octoplast's tilt and turn. It was really cool too because the Octoplast you can pull the hinge pins, and now you're just installing the frame, and then you install it, and then you put the glass back in. So it was really cool to do that, actually in a presentation. Um,
Yeah.
Yeah, it was cool.
There's lots of comments about the complexity of your system. It's obviously different. It's a lot of steps, building interiors, stops and all that. That is different and requires more steps than popping in a flanged window. But what I like about Josty's development of it is basically think of it as you pop in a frame, tape the edges, pop in the window, and the window is installed. Right? That's the ultimate goal, kind of.
Yeah, and it was funny because I kind of blew him off at the Chicago BS and Beer, and then I get this email, and it's like, Yosti. I mean, I used to get called that when I was a kid occasionally, and he's German, and and it's interesting because in German it's not uncommon for people to take last names and turn them into first names. But I get this drawing from him, and it's like, holy crap, he's completely riffed on this in a way that I would never have imagined. So it's a lot of fun.
Can be a great opportunity for somebody like you were saying, Peter, like a Huber or something like that to come. And this is a full integrated system where it's now your weather barrier system, your primary flashings, the window buck, the mating surface is all part of an engineered system to try and, lower that bar a little bit.
I can't tell you how, I'm like this to the problem. I'm thinking windows, windows, windows. And then some kid comes up to me and says, they're openings, and I thought, damn.
Yeah.
Really cool.
If there was a perfect spot to put that separation in the gasket, because you've installed the back dam, or excuse me, because you have suggested that it's mandatory to have either a pitch sill and back dam, or at least a back dam, would the best place to break that gasket be the midpoint, the middle at the bottom, like the furthest up point in the sloped sill? That's where you could break it, because we could potentially, someone could just do this in the field. This doesn't have to be, the magic of the window manufacturers redesigning their entire facility in 16 different things. You could just buy really damn good adhesive and really damn good gasket, and every non-flanged window that you get, you could go ahead and lay it on a set of horses and painstakingly wrap your gasket around. But I think you want to turn that corner and break it at the bottom. Or I guess you're happy with the break at the corners? I don't know. I'm trying to think about lowering the risk. I was like, oh no, we put it right at the top in the middle. The middle top of the window never leaks. It's always the corners.
Yeah, that's a really good question. And I think we'll probably end up welding this if they meet that they'll be welded. But you triggered something else when you were talking about this, in that both Steve and Cody think that this should be done on site. They do not want the manufacturers to do it. I'll bet you the manufacturers are going to say, knock yourselves out because, you know, what's,
Factories are expensive.
yeah.
Now it's your problem, not our lawyer's problem.
Well, that's part of it. But when I did this presentation for BS and Beer in Chicago and in Portland, I was talking about Pella's Steady Set. You know, Pella at IBS 2 years ago, or maybe it was last year, I don't remember. They have this new installation system, and they are stepping in more than toe deep into taking responsibility for installation. Um, so I know the guy who is one of the main researchers there. He actually, I met him doing wingnut tape testing, and I was testing Pellets tape because he was working. You know, he said, "I'd love to work with you as a wingnut." But my first question to him was, "How did you get this past the Pella lawyers?" You know, that probably took as much time as the research and development. Um, so it's funny that I came up with this presentation in October of 2024, no, of 2023. But anyway, right around the time that Pella was, commercializing the steady set system. So really interesting that my attitude was, well, the window manufacturers don't take responsibility for installation, and they should. And then what happens? One of the major U.S. manufacturers steps into that arena.
What do they call that? Convergent evolution.
Mhm.
Yeah, 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 absolutely. Like with the car door gasket manufacturers, converging solutions.
Yeah.
So is
Go
it
ahead.
Jeff King that's busting our balls for not getting the questions in here, guys? Do we
Yeah.
have do we have a preferred question next?
Jeff's
One-
king of wingnut too, you know.
Yeah, I got no problem with it. Take issue. Let's serve our constituency here, right?
Yeah. Jeff asked, what's the chance of a nearby fire melting the gaskets?
Oh, urban wildfire.
Yeah.
I would say if burning embers and brands get to that gasket,
Your house is on
you
fire
have
already.
other problems.
How
Get
about
out now.
silicone? We could do high
You know
temp
what's
silicone.
funny? This issue comes up too with rain screen in urban wildfire areas.
Mm.
You know, you and the solution from Fortified Home, you know, IBHS, the Institute for Business and Home Safety, they have a particular gauge of screening that you need to use to keep brands and embers out. And if you do that, you will not get the brand or the ember getting into that space. It doesn't mean it can't, you know, lean up against the building and put flames up in there or heat, but it just means that it can't get sucked up in and really get the wall going. I
Unless
worked
we're
on a project in Portola Valley where, in addition to doing that mesh, we painted the mesh with an intumescent paint so that if it got hot enough, the intumescent paint would close off the screening.
so if there was a nearby fire, could you completely completely negate your entire rain screen system?
You
Just
would.
have to rip off all the cladding so that we can read.
The house
No,
didn't
no,
burn,
no.
but now the
No,
walls
no,
are
no.
gone.
You just you rip out the screening and put in new screening.
Oh, okay.
Serviceable screening.
But if you really want job security, you make it so that you have to take the whole wall apart.
That's right. We should just coat our homes with intumescent paint.
Sure, walls.
Do the whole exterior. If there's a nearby fire, it'll expand to protect the home, and then we just have to replace the home. It's no problem. We're happy to do it.
Okay, you guys need hats, man. You are really
Oh, goodness. All right. What was the next favorite question, gents? What do we got? Window installation talent, good is the enemy of perfect. That's just a true statement. Fighting over the last little bit is sometimes difficult.
Richard Price mentions, I worry about a blind seal. The flashlight test is a good idea, but will that gasket last 20 years? And to me, will it last 50 years? That's my preference, to design a house that'll last 50 years without much maintenance or much replacement.
That is a great question. And interestingly, the car door manufacturers are, I think that this fellow said that they're surprised, given that if you protect their gaskets from UV and ozone, they last a lot longer than you'd think. Secondly, if the gasket fails, you pop the trim, you pop the window, put a new gasket in, pop the window back in. That's a lot less complicated than, ripping out sealant and tape.
Yeah, I'm a big fan of, if we want to make arguments to tear something down, we have to show the replacement that we're comparing it to. And if my house burns now, or if there's a fire next door, my windows aren't better protected without the gasket. The tape would melt. If we're going to make these other comparisons to, is the gasket an inferior system in this situation or that? Well, inferior as compared to the existing systems, because I would say a high temp PDM gasket is better probably than most acrylic tapes at fire resistance. To Ben's point about the silicone gasket, I realized I went back to fire. Sorry, I was still thinking on it. My brain's not as fast as yours, gentlemen. Just kind of thinking through that. We always need to be comparing these things not to a perfect alternative, but to the alternative that we're currently using. And for replacement, as you were just talking about, it's a pain in the ass to pull out a window. You tear off the trim, you tear up the tape. It's really hard to reintegrate with the WRB that's been mangled as you've been removing these components, and you've solved that.
And I can't wait to hear my wife's response to, "Hey dear, I'm going to add fire testing to my tape tests."
That garage is going to be real fun. Oh, I love it.
It's got an ancillary fire benefit too, because if we stop airflow, if this creates an airtight assembly, we're less likely to be sucking embers and brands into the building to be able to start a fire.
Well, and in terms of water management, installing a flanged window with a full barrier system is quite simple, but those of us trying to do better always do sill pans, and that adds quite a level of complexity. To do a sill pan, to try to get crews to do it properly, you can risk risk things and just go with full barrier systems, but you will eventually have some leaking windows that destroy your framing and cause mold and all that stuff. Is that, would you agree with that, Peter?
I wish I could get the tape out completely, but I think we're going to have to continue to flash the way the WRB meets that frame. We added stops, so we have to go around those, but that gasket has to meet up to something that's watertight from there out.
Yeah.
Now, Yosti's system is a bit different, and we might be able to do a boatload less taping, because really, you're probably only going to have to tape the flange of his assembly, not the flange of the window, of course, but so that might be another advantage to his system.
Right.
Well,
David Gersto just asked, there are details to be worked out. There's a lot of training to do. The idea of installing from the interior is a breakthrough. So his question is, what is the biggest remaining problem to solve?
Whoa.
getting kids into skilled trades. Sorry.
Well, I think he means relative to the window, but I think it's okay to broaden that a little bit.
It's the same thing though. It's the people are the ones who are going to screw this up, right? Like we can figure out great materials. Actually, how about if I shut up and let our guest answer the question?
I think that Ben and Yosti have it right, which is that the next big hurdle is to start to work with manufacturers, because we're practitioners. There are a lot of things about material performance and systems that we don't know because it's not what we do. So I think that's the next big hurdle is, um, where's there are companies out there that make windows and make enclosure pieces that are always looking to capture more market share by integrating more functions. So we're just planting seeds to see what might happen.
And I think, Peter, you touched on this before. I think a lot of us practitioners feel like these manufacturers are like having these great conversations with practitioners to develop these things. But just in my experience from the manufacturers I've had the privilege to work with, a lot of times they're just operating in a silo and they're just looking at the materials and resources they have in front of them and trying to figure out what they can cook up that's a little different than the last thing and then see if it sticks instead of putting the two together. I got to work with a company a few weeks ago in Cambridge for product development. That's all they do. They're the company that created the mouse originally. Um, and they have this thing they call KOPs. When they work with manufacturers, they bring in a KOP, and it's a key opinion provider. And they won't do a product development round unless they bring in KOPs, which are outside practitioners to sit down and say, no, that's a terrible idea. And so if we have any manufacturers in the room here, reach out to practitioners because it's incredible the void between all of us.
Yeah, I know I talk about Steve a lot, but he just came back from, a bunch of from a European trip working with manufacturers. And, to have somebody that designs buildings, installs windows, and then goes looking to see how the manufacturers make their products. That that's why I like to tap his experience, because we just don't have that many people that are crossing that many sort of industry boundaries. And Cody's another example. Really funny. When Steve and I went down to the Laurel Design Center in Boston, I had the mock-up with me. And I said, should we throw it in the back of your truck? He goes, nah, they're going to be all salespeople. So we get down there, we can't find a place to park. And so I called Cody. I'd never met him before. I said, hey, Cody, we can't find a place. He said, oh, I'll come down and show you where to park. So this guy comes walking towards us, like 6'4", cowboy boots, blue jeans, and a flannel shirt. And I thought, God darn it, I should have brought that mock-up. Because as soon as I started to talk about gaskets, he was like throwing his hands around and, oh yeah, that's a great idea. It turns out he's a former builder and has done tons of installations. He's a very atypical dealer. He actually goes like Steve going to job sites and installing windows. Cody's a Windows salesperson who goes and installs the windows he is selling, and that's the crossover that really, makes stuff like this happen.
I'd be remiss if I didn't point out that Mike Girton has entered the chat. If you're going to pull out David Gerstel and quote these other great folks that are kind enough to join us on these conversations, I have to read Mike's comment. If a window had a gasket around, don't scroll up too fast. If a window had a gasket around a perimeter of the inside edge, it can be pressed, pulled against the bucked opening. It eliminates the need for the sill gasket transition from face seal to bottom seal and can be prepped in the factory. And then to double down, Doug Horgan says, I was thinking the same, Mike. So two people way smarter than me both agree on the same thing, and they continue to chat through it here. I guess Mike points out to Doug that it's the interior versus exterior install. Do you have comment on that, Peter? Do you think that we should just commit to we're going to keep installing windows from the exterior? We reverse the challenge to it by having the buck drain to the exterior. Is that something that you believe has merit? Or would you like to disagree publicly with Mike Girton on the record right now and say, no, Doug Horgan, you and Mike Girton, you guys are way off?
My first question is how much have they had to drink? And then I'll answer the second question. No, I was convinced we have to install them from the inside, but then Yosti comes up with his system and the windows are not installed from the inside. So, let's just see what works best. It was funny as I was doing, just before I started to show the slides, I thought, I hope nobody asks me, Peter, how would those 22-foot tall wooden windows be installed from the inside.
That's a good point. How
Right?
would
They wouldn't be.
they? Right.
Carefully.
No? Yeah, because those suckers are, I mean, we had to have this enormous, because the stair tower is on the far side and it's a steep slope. So they had to bring in this huge crane that barely fit up the driveway just to lift these. I mean, I don't know how much these weighed, but 800 pounds maybe? I don't know. They're these big, like mahogany wood frames, just batshit crazy. But I mean, the building is beautiful, but it's also like the most challenging enclosure with, crazy angles and curves coming into, you know, square. It's a nightmare.
Travis, I'm also not sure if you, sorry. I
No,
was gonna
it's to walk through the house. It is beautiful, but building scientists just they get all itchy.
Travis, Doug also named your band if you ever need it. It's called Rage Against the Fajitas. So that was identified.
Oh, I missed that. That's perfect.
I thought it would be I Love Taco Bell.
Oh, you're
Well,
way
you
off base
complain to
now,
have
Peter.
them
You're way
make
off
your
base.
own tacos. Not only are they pre-made, they're sort of pre-digested for you.
They look the
Grilling
same
into
at every stage.
Oh,
don't they?
damn, there goes that Taco Bell endorsement that I was hoping for.
Demonetized.
Oh, good thing you're big in flashing tapes. Actually, it was heat
Well,
tape was the last time I accused you of being on the inside track. So I like that we keep this going. We just constantly claim that Peter's got inside deals going.
What I'm waiting for is Steve to close us out with one of his podcast ending jokes. Come on,
Do you have
Steve.
a quick pun typed in there?
Yeah.
We did get you to go an extra half hour. So I feel like we really swindled not just our viewers, but also our guest host, which is just a win for everyone.
Yeah.
Well, I love the BS and beer. It's fantastic. So happy to be here with you guys.
Thank you very much.
Happy to
We've
be
enjoyed
here.
the conversation. I don't think I had official host responsibilities. Ben, are you supposed to close this out? What's
I
happening
think
here?
I'm technically the one in charge here, so I'm going to say, Peter, thank you, sir. Audience, thank you for being here with us. It was a great conversation, and I appreciate you all.
Take care.
Cool.
Thanks,
Good night.
Take care,
Steve's
everybody.
fun. Yost, your family tree is a reef.